If circles are drawn taking two sides of a triangle as diameter, prove that the point of intersection of these circles lie on the third line. So I'll explain the diagram. No, actually I want you guys to draw the diagram. Just think, it's going to be tough. It's kind of confusing, the question, but think, because only if you try, then you will get to learn better. Okay, first thing first, they're talking about triangle. So let's draw a triangle for the sake of understanding. Let's draw a triangle. So what they're telling is, if circles are drawn taking two sides of a triangle as diameter. So we have, say, side 1, this side and this side. If we happen to draw a circle with, okay, that's not a good one, but something like this. So this side has, this side of the triangle has a circle with that length of the triangle, side of the triangle as the diameter, and this length will act like diameter for another circle, something like this. A better diagram, actually, I'm not doing a good job. Okay, something like that, wherein this will join this and so on and so forth. So what they're asking is to prove is this. See, when two circles meet, this is one of the possibility. So there will be two point of intersection. We have to prove that if this is one of the point of intersection, the second point of intersection will be on the third line. Okay, so let me do that over here. So I have two circles, and that's point A and this is point B. These are your point of intersection, and we have the first diameter and the second diameter, and the third line completing the circle, sorry, triangle, will pass through the second point of intersection. So as you can clearly see, it does. So let me complete this. This is point M, that's point N. This is your first circle, that's your second circle. Okay, so this is your diagram basically. So this is one of the centers, that's the other center. So now let's talk about the diagram. Consider two circles intersecting at A and B. Let AM and AN be the diameters. So to prove point B lies on line segment MN, or MN is a line segment. So my way of proving is a bit different. So I'll explain why and how. So I'll tell that, okay, let's consider that MN is not a straight line. So, but what will I do is I will join AB, MB and BN. So say this are not straight line, MN is not a straight line having B, but say these are your points A. Okay, let me do it here, actually that will be better. So we have point AB, and MN is in a way wherein it is not on a straight line. Okay, they are not collinear basically, right? So this is your scenario. This is what I am considering. Or we can prove that MB and are collinear. Even this is okay. Or we can prove that, or even proving M comma B comma N are collinear. So by doing so, we'll be able to prove the required. Okay. So these are all the ways that we can prove. So now let's talk about the proof. As Mn MA is a diameter, what can we tell about angle ABM? ABM, that it's equal to 90 degree, right? But why is it so? Because angles in a semicircle are 90 degree. Now, similarly, we can tell that angle A and B is also 90 degree. Why? Reason is AN is a diameter. Okay, so at last, if I add equation 1 and 2, what will we get? 1 plus 2 will give me angle ABN plus angle ABM is equal to 90 plus 90, which is 180 degree. So by proving that this is 180 degree, that these two angles add up to 180 degree, what can I tell? This implies MN is a line segment. That is angle, the reason being angle ABN comma ABM form a linear pair. So by proving so, we just prove that all of these 3 points are on the same straight line, and so point B lies on AN. Hence proved. So this is your proof.